Hi, and welcome to a snack-sized episode of Home the Second Story. I'm Sheri Scott from Springhouse Architects in Cincinnati, Ohio.
And I'm Marilyn Modinger from Runcible Studios in Lancaster, Pennsylvania and Boston, Massachusetts. So, we're talking about HVAC today.
So what does that stand for?
Heating, ventilation, and air conditioning.
Yeah.
And hot take right out of the gate, HVAC, not HVAC. We do not say HVAC.
Oh, yeah. It's been a long time since I heard that.
I don't know. I mean, you can call it whatever you want, I guess, but no, we don't call it HVAC.
Noted. I'll never call it that again, I promise.
This is a big topic because it's one of those things that is sort of hidden when a house is finished, but is incredibly impactful, both in the design and the comfort of a home. So when you're designing the home and you don't think about where all the ductwork is going to go, you end up with soffits and chases and all this gross stuff everywhere. Or you end up with a system that doesn't work very well.
It has to do with the comfort of the home, right? Like we take a lot of time and a lot of effort, and so do our clients, to get the, what it feels like to drive up to it, what it feels like to walk in the first time, what it feels like to sit and have dinner with your family, and designing those spaces. But designing those spaces is also how it feels, temperature-wise, humidity, clean air. All of those things are within the HVAC.
That's right. And also the longevity of a house. So if the HVAC is poorly designed and humidity isn't properly controlled, or, that kind of thing, then it can actually have horrible detrimental effects on the longevity and the health of your home. Mold, or poor indoor air quality, or bad ventilation, or the wrong kind of ventilation. So when I was learning how to design and install HVAC systems as part of a high performance home, we always used to say, build it tight and ventilate right. So people might remember that phrase from, 20 years ago, but it's still very, very true. So as houses have become tighter, more well insulated, better windows, better doors, all that kind of good stuff, you have to pay attention to HVAC a lot more carefully for both the design of the system and the comfort as well.
And can we just dispel the myth that houses are too tight now?
Oh yeah,
They're not too
right
tight.
No.
They are not too tight. Just your HVAC system is bad.
That's right.
It's not calibrated for how the tightness of the house or the less air exchanges of the house. And it did take a while for those things to kind of catch up to each other. I do feel like in the industry, we were tightening up the house and there wasn't enough air exchange, and the HVAC system didn't keep up with that change for a while.
That's right. And also, I think, when people say, but houses need to breathe. Well, yeah, they do. Absolutely. So do people. We need to breathe as well. But we breathe through our mouth and our nose. Like we breathe through a controlled location. We don't just breathe through wherever, right? So that's the same with a house. You want to breathe. A house should breathe through controlled location. So we want to have controlled air coming from the outside, make sure it's filtered. And then also make sure that it's not in the wintertime freezing cold and you just dump that cold, fresh air into the house. And now you haven't conditioned it, it's not warmed up or whatever. So yeah, so maybe we're getting a little ahead of ourselves maybe with that, or I am with that comment. But let's back up and talk about when in the design process do you start talking about HVAC design? When do you start?
Right after we get kind of the floor plan scope, because we always do new houses. So we talk about it after our scope is established and we know which orientation the house is. We know how many windows we have. Of course, in my practice, we do not size any HVAC systems, but we need to know early on where the units are going to go, where the outdoor units are going to go, how the trunk lines are going to spread out to distribute the air throughout the house. So that happens right after we get the scope of the house.
well, same for us. We talk about it since we do a lot of renovations of really old houses. We actually talk about HVAC even earlier. Very in the very schematic stages of a design, we're talking about where are those trunk lines going to go, because oftentimes there is no room to do anything.
Right.
And the design itself may be designed around chases or ductwork because there's literally nowhere to go with it. So we'll start very early, but I think, whether it's in a new home, you don't have to start on day one with it, but you are starting very early.
Yeah.
And what both of us said, what neither of us said is you wait until construction and you let the sub figure it out. We are not saying that.
We did.
That's a
you
bad
would never
idea.
hear me say that. No.
That's a bad idea. So, I mean, you certainly wouldn't do that for other things. You don't wait until construction to figure out the structure. You know, you don't wait until you're standing there digging the hole to figure out what the foundation design is. No, you figure that out ahead of time.
Right.
And HVAC is the same way, or should be the same way.
Yeah, that's true. And in residential, at least around where I am, we don't hire engineers to do the engineering of the system, to size it and to plan out all the duct runs. Our subcontractors do that. And of course, as an architect, we are not in control of the subcontractor. So another reason, where we've talked about many times on other episodes, we don't have to get into again, is to choose your builder early, because then that brings in their subcontractors and more coordination of everyone it leads to a better product.
Absolutely. We do often use an HVAC engineer on especially our historic homes, when we're trying to dial things in. It's like a Swiss watch.
Right.
And Massachusetts, our projects in Massachusetts, Massachusetts has very stringent energy code. And so in order to meet that, we have to reach passive house levels almost in a lot of projects. We are required to do a HERS rating, which is a method of
like measuring the air exchanges.
Measuring the whole entire house. So it's about insulation and windows and the system and everything. So we're required to do a lot of that stuff, and an engineer is really helpful for that. Now, I will say this, it has to be an engineer who's used to working on residential projects, who isn't going to come in and oversize this huge thing or over design it or get crazy. So we have a good working relationship with an engineer where he sizes the equipment, he sizes the ducts, and then he gives us a range and he says, this is how many CFMs I need to move through this duct. So then I can size the duct and say, okay, well, I can have it be 2 inches by 24 inches, or I can have, which is insane for a duct. Like, you would never do that except in extreme circumstances. And so we do actually size everything, but in conjunction with the engineer. And then when the sub comes on board, then the system's already designed, and then the sub is there to execute, but also to weigh in on some of the things. But the sub is not telling us the sizes of things. We often find that the subs oversize things or don't quite understand the physics behind the system. So I've had some tough conversations about, like, well, but the physics says the air doesn't move that way, or, that would cause a lot of friction loss, or whatever the case may be. So you want to have a sub who is sophisticated enough and who understands that, because there are those guys for sure.
Right.
You can do the manual D, the manual J, and do those proper calculations.
Speaking of oversizing, I do have 2 examples that I always draw on, my own examples. Number 1, I lived in a small ranch house, and it was on a slab, and so the furnace, the HVAC system equipment, was in a little closet right off of my family room where I watch TV. And when it would turn on and off, it was so loud that it was a tiny little house, right? There's no reason. Either it was a really cheap system, which it might have been. I didn't build the house. Or it was sized incorrectly because it turned on and off a lot. And obviously it could have been sound insulated. all the other things. But the other thing that is more important for me to remember is bigger is not always better, because in my business is called Springhouse Architects, and it's because I started growing my business in a stone spring house in my backyard. So quaint, right? And all we had, it was a one room. It was 20 feet by 10 feet. And I had a mini split on the wall. It was oversized. And so it would run to take all the moisture. It was just stone on ground. So it drew in a lot of moisture, and it would run to air condition the space, but it would get cool faster than it dehumidified.
Yeah.
And so it would turn off, and then the humidity was still in there. So it felt really weird and clammy and started getting moldy. And finally I called in the right person to size it. And he's like, well, yeah, Sheri, your unit's too big. I'm like, okay. So we actually sized down an appropriately sized mini split system, and it worked great. It took the humidity out. It conditioned the air. It didn't just make it cold.
That is such a great point. And that's a testament to finding the right subcontractor who understands the physics and understands how to size everything.
Yeah.
That's huge. Let's talk a little bit about different types of HVAC. So there's air to air, air to water, there's water systems, there's gas powered, there's electric, all that kind of stuff. What kind of systems are you usually installing these days?
Well, you probably have a deeper breadth of knowledge than I do on that, because we do rely on our subcontractors. We are concerned more about duct layout and runs and how we're designing that. We do always make the decision, or help our clients make the decision, between gas and electric, which is becoming easier now because most people are trying to get away from gas and use more electric. I do not know enough to have that conversation of pros or cons. I know that gas is less expensive to run, but electric is more sustainable. And then geothermal. We have a pretty good knowledge of geothermal. It comes and goes in our practice, honestly, due to tax credits. If you have the wonderful federal tax credits that pay you back a third of the entire budget, that is a no-brainer. If you're not, you're probably making that decision to be off-grid or just to be more sustainable.
And geothermal is coming up more and more for us as well. In the city, when we're working in tight urban conditions, geothermal isn't possible because we can't drill wells if we're on a zero lot line situation or a tiny little backyard or something like that. We can't drill wells. But in Massachusetts, we're doing all electric because basically the energy codes are such that we can't do gas or oil. And we're also doing all heat pumps. So that's something that I do want to say a quick word about, because a lot of people are like, heat pumps are not good in cold environments.
Right.
That is not true.
Correct.
That used to be true.
It
but
used
now,
to be true.
Used to be true. So there's a lot of sort of old wives' tales still sticking around.
Yeah, that's true.
And that's one of them. So heat pumps in my own house, which is an uninsulated stone, basically castle. It's like these 2 feet thick of stone walls. And so very well air sealed, because air doesn't come through 2 feet of stone, but not well insulated. Those stone walls, 2 feet thick, have an R value of 2, believe it or not. I have all electric heat pumps. And in the coldest parts of the winter, I have to wear a sweater, but for the most part, it's completely fine.
Do you think you have to wear a sweater because of the radiant cold from the walls, or because the heat pump can't keep up?
I choose to keep the temperature set lower because I just don't want to run it all the time. And the bills can get pretty high. And also I don't need it to be 80 degrees in the wintertime for me.
Sure.
Like I just don't, or even 75. So that could also be personal preference. But the heat pumps can absolutely keep up. And it's just that if you're expecting the house to be at, 78 degrees perfectly all the time, when it's -10 outside, That's just not going to happen at all. So in that circumstance, sometimes it is better to do radiant, hot water, so radiators, or something like that. And certainly in more northern New England, that's definitely what a lot of people do, or mountain climates or whatever, because the heat is so nice. It's not hot air blowing on you. It's radiating from the floor. It's super nice. The problem with that is, though, that then you need to do air conditioning. So you still need a duct system.
The entire system, the entire thing. Yeah. And we've had a few clients ask. We've had maybe 2 in all of my time do radiant floor heating and then an air conditioning system. But most people, and we have a lot of people ask about it, and we say, it's great. It's not drafty. It's all the things, not dusty, but you have to have a whole nother system. Like not only is it expensive, but you're also doubling up essentially. So I don't have many people take me up on that.
No, and the radiant systems run on a boiler, which you should not have an electric boiler. That is not a good idea. It's too expensive, and it's just not the right thing. So someday we'll talk about water heating and instant hots and all that kind of stuff. We'll talk about that another day. But let's get to that duct layout, because that's your point about having the 2 systems. So if you have the radiant and you have to do the AC, you're going to have a duct layout anyway. So let's talk about duct layout and like how does that work for you guys in terms of, laying that out so that it doesn't negatively impact the design?
Ours is pretty simple because we can really put it anywhere we want and make changes in the design to make it work.
Sounds delightful.
I know. It's pretty simple.
And luxurious.
The only place we tend to have a problem with it is in the basement. So everyone says, I want, we're pouring new basement walls. So it used to be everybody had 8-foot basement walls. If you had to soffit down for a duct, you're soffitting down 10 inches or 12 inches. So then you have a 7-foot ceiling. That's the typical like basement feel.
Yeah.
Now it's just standard. Everyone does a 9-foot wall, which ends up 8 foot 9.5 inches high for weird reasons, but 9-foot basement wall. And now still, if you have to come down off of that, you're still coming down another foot. So then you're under 8 feet tall at those soffits. So the trick is trying to find how you can run that duct that has to go below the joists in an opportune place so that you're not coming down the stairs and having a dropped ceiling right in front of your eyes, right? That soffit. And well, you will have to have a soffit somewhere, because then you can go back up and
that's right, up in the joist bay,
up in the joist
for
to
your
get
laterals.
to the edges.
Yep.
And at the same time, define where that run needs to be, where it wants to be, and then design it into the architecture of the space with tray ceilings or running down an entire hallway, that kind of thing.
Right. Or like above a closet, or like a series of closets, or behind. Yeah, exactly.
And that's really all we need to get into. I mean, we do always allow for space on each level for a unit. We don't always need it. If it's a 2-story and our units are in the basement, we try to put a whole another unit on the second floor.
Yep.
Usually we don't need anything on the first floor unless it's a slab house. So we don't have any mechanical space under. And then we have to account for that space just for a closet to put the unit.
Yeah. Well, and the units aren't that big, especially if you're doing
really
2
not.
of them. Yeah. It's really different world these days. If you're living in a house with a 30-year-old HVAC system and you're looking at replacing it, it is a different world in terms of the space that the equipment takes up. Certainly the ductwork is still the same. Air, right. It doesn't matter what the technology is, like air still takes up the same amount of space. As far as duct layouts for us, I mean, obviously working in older homes where there is sometimes no joist bay, where we have solid walls, where it just gets really complex. So we have a whole playbook of sneaky ways that we can run ducts around. And it's actually one of my most favorite parts of the design is finding really creative ways to slip the ductwork this way and that way,
Right.
understanding how to keep elbows to a minimum, to keep the air moving, that kind of thing. So one strategy that we will use on an older home that doesn't have a lot of space for ductwork is we will actually do 5 or 6 pieces of equipment, not 2. So even in like a 3 or 4 story situation or a 3-story house with a basement, we will do several pieces of equipment. So we might do a mini split in the basement. We might do a mini split on the first floor in a part of the house where we can't get ductwork over to it. Then in the main part of the first floor, we'll do a unit that takes care of the first main area, the main floor. We'll do a wall pack or like an in-ceiling thing, or we use a lot of Mitsubishi stuff, and they have like a whole collection of different like pancake units and wall things and all these kind of different things that help that we can kind of slip the equipment in different places. And when you're dealing with some of those pieces of equipment, they don't have ductwork. They're ductless. So people know about mini splits and they picture the sort of the wall cassette thing.
Yes.
But there's a whole wide world of like other sort of ductless systems.
And they do make them ducted also, right? I've never used them, but I mean, I could see where that would be useful.
Yep. And that's where our engineer is really helpful because he is up to speed on all the different, this is what Mitsubishi's coming out with this year, or Bosch or whoever. And he's like, this piece of equipment can be really useful to reduce our ductwork. Because ultimately, as much as I love being a wizard with laying out ductwork, if I can eliminate some of those things. So we will do actual 3D models of our ductwork and our duct layouts, especially when it's a really complex traffic jam type area. So we'll actually do them, we'll color code them. And we've had situations where we've designed it down to the 1/2 inch, and the subcontractor is installing it. And he's like, yep, it was down to the 1/2 inch, but it all fit and it all worked. So I think that to me is a really exciting moment in a project because it's never seen. Not every client really appreciates or cares.
I was going to say exciting for who exactly?
Well, we do work. A lot of our clients are like engineer types or tech people or whatever in the Boston area who do kind of nerd out about it. But I would say that's partially like that's the kind of client we like to work with, is someone who does appreciate that level of refinement and that level of involvement. But in terms of the duct layout, I think, if we're zooming out from your projects and my projects, I think like what we could say to people generally is that you don't have to listen to whatever the subcontractor is saying as the first thing. So I've had subcontractors walk in and say, well, I have to drop the ceiling on this whole floor.
Oh, the entire thing. That they love nothing more than to do that. Yes.
Yeah. And I'm just like, so that's going to cost a ton of money in extra framing and, all that kind of stuff. And you're losing a foot of ceiling height in the whole place.
Yeah. No.
So this is one of my like phrases I always say is that often subcontractors will suggest things because it is the easiest for them, not because it is the easiest for your project. Yeah. Even the good ones, right? Like that's just human nature, is to suggest things that are easy for you. So I think, as we're imagining how people could take this information forward in their own projects, getting an architect who understands this stuff and who's saying, yes, we're going to lay out this ductwork for you. We're going to interface with the sub and make sure that this is done right. That's why it's important to have an architect who's doing more than just drawing up plans, because that architect will not be there to help you navigate all that. And you'll end up with all these soffits and drop ceilings and terrible stuff that ruins the design.
I agree.
So
well said.
So yeah, I mean, I think that's probably a good place to wrap it up for today. But this makes me think that there's a ton of other technical stuff that we can talk about related to HVAC and the technical guts of a house, because we do all that. We advise our clients on all of that.
We advise them. I would say that I don't necessarily know it all. And what do I tell my clients? I tell them, I don't necessarily have all of the answers, but I know all of the pieces and parts, and I know the right people to talk to bring into your project, because I cannot know all the latest Mitsubishi
me neither.
things that they're coming out with, but somebody does, and I work with them.
That's exactly right. So we generally, as architects, like, we are going to be thinking about all that stuff and asking all those questions and facilitating getting the right people in, and also being able to help people talk through the pros and cons, right? Like, what is the pro? I can't design a radiant floor system and the piping and the boiler. Like, I understand how it works from a physics perspective, but I can't design the system. But I can talk about what are the pros and cons between a radiant and an air system and a whatever. So
yeah,
that's what we're here to do.
I love that. Good.
All right. Well, thank you for joining us today on Home the Second Story for a quick snack. Questions for us or topics you'd like us to cover, or are you interested in being a guest? Reach out to us at admin@htsspodcast.com and follow us on Instagram. See you next time.
Thanks for listening to Home, the Second Story podcast. Feel free to share this episode with a friend. Contact information for both of our architects are in our show notes. And don't miss future episodes. Follow or subscribe to our show for free in Apple Podcasts, Spotify, YouTube, or wherever you're listening right now.